All right, so we have example number 2 from our 4.4 packet here, which is graphing a cosine curve with a bunch of transformations going on. So I'm going to go through a pretty quick method, again, using just transformations to graph this. So I'm going to start by graphing the midline. And I wrote the amplitude there. So remember, our midline comes from back here. Let me get my highlighter out. This -1, that's our vertical shift. So I'm moving the whole graph down to -1 as the middle. So I already put that on my graph as that yellow dotted line. And then thinking about the amplitude, I like to think about that for the scaling of the y-axis. So here I'm not going to change the scale on that graph. Next, I'm going to look at inside the argument in the parentheses for the phase shift, which is this x plus pi over 3. And remember, we go the inverse operation, so I'm really subtracting pi over 3 from my x values. So I'm going to start now just putting points on the graph, and it's helpful to think about the scale for your x-axis now. So sometimes you can kind of just guess and check, but I like to take into account really 3 things for this. The first is the period of the graph, and since there's no horizontal stretch or shrink, that would be in front of the x as a coefficient, my period is still 2 pi. I also like to think about the distance between key points, which I talked about in the video before. So to find this, I'll do a really quick review right now. We think about our original cosine curve, and I had these 5 key points on there. So those 5 key points actually split our graph into 4 little sections, like this top part, second, third, and fourth. So if I take the period and divide it by 4, that's the distance between my key points. So I need to make sure on my graph, when I scale my x-axis, I know how far pi over 2 is on the x-axis. So with that in mind, I kind of look at 2 things. I look at the distance between the key points is pi over 2, and my phase shift is pi over 3. So what this means for me is I don't want to just scale it by pi over 2 because pi over 3 is smaller than that. So I want to make sure I know where pi over 3 is on the graph. So to get my scale, most of the time it works if we get a common denominator between these 2. So I'm going to scale my graph. I'm going to make one line pi over 6. And you can make 2 lines pi over 6, but generally this, for the most part, works. But you just have to think about, again, your shift and how big the period is, so make sure that can fit on your graph. So I'm going to write on here my first, I'm going to make 2 lines pi over 3, which means that first line would be pi over 6 there. And I'll mark a couple points, right, just to go through. So let the video play a little bit. But now thinking about my transformations, so we said that this graph is moving to the left pi over 3. So I went over here to negative pi over 3. And you have to think about what your parent function looks like now. So since my cosine curve, right, starts at the max value, I need to go my amplitude 2 units above my midline. And that'll be my first point. All right, and then thinking about the shape of our cosine curve, I'm going to move pi over 2 units to the right. On my graph, pi over 2 would be 3 lines, right? 3 pi over 6s. So I move pi over 2 units to the right, and that's where I put my next point, right on the midline. And then I'll move pi over 2 units to the right again, and put my minimum point. So we know our cosine curve is this curve that goes from your max all the way down to your min and back to the max. And I can keep that pattern going and fill in a couple more points. Sometimes I'll ask for at least 2 periods, but again, as long as you know some key points on your graph, like here, if we had to, we could label our max points. So I've got a max point over here at negative pi over 3, 1, and a min point over here. This would be 2 pi over 3, since I labeled my x-axis pretty nice. I know my units, negative 3. So just making sure we could pick all those out. And again, you could always sub points back in your equation to make sure they all look good.